All right, let's look at the first application of pointers. I told you that using pointers, we can efficiently pass large amount of data between our functions. So instead of copying data around, we can pass references to data. Now, in the first part of the course, we solved this problem using reference parameters. That's one way, which is the modern and preferred way, but we can also solve this problem using pointers. Here's an example. I'm going to define a function called increase price and give it a parameter of type double called price. Now here we're going to take the price and multiply it by 1.2. Now in our main function, we're going to declare a double called price. Then we're going to call our function and pass the price. And finally, we're going to print the price on the terminal. Now you know that when we run this program, we don't see the updates to the price. We see the original price because by default, this argument is passed by value. So when we call this function and pass price, a copy of the value stored in this variable is taken and stored in this parameter of this function, which is like a local variable in this function. Now, in the first part of the course, we solved this problem using a reference parameter. So the only change we have to make to this code is adding an ampersand right here. With this, we're declaring a reference parameter. So when we call this function and pass the price, no copy is taken. Instead, a reference to this variable is passed to the target function. So in this function, we can access the price variable that we have declared over here. And any changes we make to this variable in this function is going to be visible outside of this function. So now when we run our program, we see 120. That is one way, which is the modern and preferred way. Now we can solve this problem using pointers as well, but there is a bit more work and our code is going to be a little bit more complex. Let me show you what we need to do. First, we need to declare this parameter as a double pointer. So this is going to be a pointer to an existing variable. Now over here, we have a compilation error because we cannot multiply a pointer by a value. So to solve the problem, here we have to use the indirection or dereferencing operator to access the value stored at this memory location. So we get that value and multiply it by 1.2. Now on line 11, we have another compilation error because we cannot pass a number as a pointer. Here we need to pass the address of price. In other words, if we have a double pointer, we cannot set this to a number. We have to set it to the address of an existing double, okay? So that is why we have to pass the address of price to this function. So we had to make 3 changes to solve this problem. First, we had to declare our parameter as a pointer. Then we had to use the indirection operator. And finally, we had to use the address of operator to pass the address of this variable. So using pointers to pass data around involves a bit more work. Now, if you run the program, we get the same result as before. So once again, in situations like this, it's always better to use reference parameters. But the reason I explain pointers here or passing data using pointers is because you might be working on an old project, and in that project, this might be the technique for passing data around. Now, as your exercise, I want you to implement the swap function for swapping 2 variables using pointers. So here we have 2 parameters and they're both integer pointers. So we'll spend a couple of minutes on this, then come back see my solution. All right, I'm going to define the swap function with 2 integer pointer parameters, first and second. Now, just like before, we need a 3rd variable for swapping these values. So I'm going to declare an integer called temp. I'm not declaring this as an integer pointer because we don't want this to point to anything. We just want to use this variable to store some data temporarily. Now, what are we going to store here? The value of the variable that the first pointer points to. So here we're going to use the indirection or dereferencing operator to get the target value. Now that we have copied the value of the first variable into temp, we can overwrite first with the value of the second. So once again, we're going to dereference this pointer and set the value at the target memory location to the value of second. And finally, once again, we're going to dereference the second pointer and set it to the value of temp. That's all you had to do. Now let's test this. So I'm going to declare two integers, x and y. Now to call the swap function, we need to pass the address of these variables. Okay, now we can swap them. And finally, let's print x followed by a comma and y. So now we should see 20 and 10. Take a look. There you go.